Hello guys, maybe I was late for one day since I was very sick, and for today I'm not perfectly okay. So may I have some pardon for you, though since my condition is not good. But maybe I will try my best ASAP for today's review. Okay, so today's topic will be about etching. So etching process can be said as we talked for the previous class. We talked and reviewed about the lithographies. So lithography can be means for somewhat easy words, printing on the paper. And the next step, etching, will be something for the same case, cutting the paper and just choosing the part where we want to use and removing the unused or unneeded part. So this is how the etching can be made for the easy words. And let's see. Etching is, there are two typical ways. For first, chemical, and secondary, physicals. Sorry. So etching can be made as removing the material from the areas that we want to selectively. So for etching in our class, there will be four materials to etch. For first, silicon nitride, the combination of silicon and nitride, and SiO2, in short, dioxide silicons, combination of two oxide and one silicon. And then the metal for the wiring and thermal coating for hardening, and finally just the pure silicon like substrate that is undoped. So let's see. When etching, there is some critical factors. For first, etching rate. Etching rate means in a period, in a known time, how much we can etch out or remove the materials from the surface or from the part or area we want. And secondly, so selectivity. Selectivity, as it works, means how we can remove the remove the material from the area we want to get off. And there's two profiles of the etching. But first, isotropic. Isotropic can be made as all-around cutting. So, yes, here is a mask, hard mask here. And just for some easy examples, yes, this is some hard mask. And for more convenient profile, guess the hard mask is not being executed by the etching process. So let's start with etching here, the center. The most wanted profile or the result was the vertical well shaped, but in real life, by the scattering of the phonon or the lattice scattering, or by the impact of the ions or lattice or molecules, the etching will be somewhat rounded, and then finally with some rounded or circled one shape result. So you can say like this: being cut off everywhere is a round shape. Okay, and a nice tropic, just the reverse word of the isotropic. So some vertical and some shape of the world. Okay. So, and finally, the uniformity. Uniformity means how the surface that we just etched is formed and flattened and well made. So, if the etch process was well done, it can be made as the result has been came out as we want, or The surface that we just etched is flat and very nice quality. Like this, flattened, but in real life, it will be not. By the scattering or the impact, there will be some rounded here. That it means the uniformity is not good at all. Of course, there is no somewhat the best way. Actually, the method of how we prepare the method and processing is, and how it will become out, the result will be is maybe the conclusion that we want to find. So sorry. So for the etching, there will be two types. For first, wet dry, and secondly, the dry type etching. So they all use the plasma. People getting in the point of the plasma, let's see how the relativity is related. So relativity means, let's guess, if there is two material, okay, I just wanted to cut off the A from the surface, and I keep etching, and finally the result came out. But there was some etched of these materials, so those can be said as the relativity is not the wanted result or bad in our respect. So let's get into plasma's respect. So plasma is for a material. There is typically four conditions. For first, solid, hard, and unchangeable. Of course, there's some change by the vibration energy or some squeezing or strong force. And by the strong force, we can make some harm or crack or destroyed or separated. So anyway, solid is not being changed its shape on easily. And secondly, liquid type. Liquid is some just think like water, fluid and very active. And thirdly, the gas type. Just think of the air. If there is some air around here, just moving, they will pass. Our hand will pass through freely through the air. It means the air is somewhat non-shape. Just for the case, somewhat non-shape and very easy to move everywhere. And finally, the plasma. Plasma can be said like this: molecule here, or the nucleus, the center of the molecule, and then the left will be the electron. If the energy is not enough, by the orbitals rule or some chemical properties, electron is not still being affected by the molecule's nucleus attractions. But if the electron is being excited enably and have some strong energy, enough for someone like hitting, strong impact in the physical way, or anyway, then the if some other lattice hit the molecule, then it means this molecule will get enough energy and the nucleus will let the electron go. Then the electron will be in the excited state. So these two types can be as the plasma. Of course, this has more higher energy state. So from solid to liquid to gas and finally to the plasma. The by step by step, the state has to be changing, the more and more energy will be injected. Okay, and of course the shape will be more freely moved. So, using this plasma, we first by this plasma we can etch the molecules, the material as we want. For some easy words, see, if there is a material and plasma wave here and plus bias and minus bias here, then the electron will be attracted to the positive bias. Then it will be accelerated to the positive bias direction. So if the electron has some enough speed, it means accelerated enough, and then it will hit this material, and the part that just been impacted by the electron will be cut off or cracked, and this will make the etch. So the wet case, for the first, the wet etching, just easy. Some chemical properties or chemical reactants, maybe some of the bondage or weakening the bondage or destroying or disconnecting the bondage between the molecules or ions. Very easy. So they are very cheap, but as you can expect, the results will be not go as you want. It means poor productivity and hard control. But surely it is very cheap. And if you're using a wafer that is very big, and if the wiring is not very small, and if your process is somewhat if your process is somewhat big diameters, then wet drying can be an appropriate way. If you can inject some unaccuracy, and secondly, a dry way. For dry way, there's the type non-plasma using way and plasma used way. For first, plasma known way will be used as the gas and ions. Here, for the gas, maybe 18 lines chemical molecules. In English, halogen waste like argon, helium, neon, xenon. Anyway, so the chemical materials that I just said is very stable, and they will not act to other molecules, and maybe will not make the bondage between other molecules, just itself holding. So using the argon ions, since they're very stable, we inject to the vacuum's cylinder or some box glass and gave it to the plasma, and for semi AC bias, then argon will be attracted. The argon or the molecule or some electron will be attracted to the bias and will hit. And if the AC string has been changed, then the bias polarity will be changed. So after hitting here, it will get back again and hit and back and hit back. It will be repeated. So this method, the AC method will be will make some nothing deposited of the remains or some result of the metal after the etchings. So if there is some deposits that we didn't want, and after etching materials, this will make the products that we want to make somewhat bad qualities, and maybe we can't use this as a material or solid product. Gas dust, if there is surface that we want to make, and we kept hitting the metal surface by the ion impact. Sorry, plasma. Then the left thing that just came up from the surface will, the debris will be in the still process, and the process will be some remaining, and by the time pass, the deposit will be, the debris will be deposited layer, and this will make somewhat unwanted effect or result. So, and secondly, using plasma method. In this way, there is typically sputtering, which means ion mirroring, and secondly, RIE. RIE means reactive ion etching, and finally, DRI, deep RIE. Okay. Sputtering is can be said as the previous case I said. Just hitting, the ion keeps hitting, but here are some problems. Sorry. So for a few minutes ago, I talked about the scattering of the lattice. Scattering of molecules by the heat each other's thing. So if the molecules has been gathered here, and they will be attract, so plasma here and plasma here, and some ions being injected here. And by the bias positive and negative, after the argon pass through the plasma cloud, they will want to get beyond, but if the molecules being hit by other molecules or ions, they will be scattered. So yes, if the molecules keep hitting, then the V1T wave as a particle will be spread in other ways, and somewhat unwanted effect like the rounded way or some tip and rounded way like this. So this is what we don't want it to do. So the advanced way will be the RIE. Similar way, but some difference. For the RIE, they have some good selectivity, then the sputtering. Not just letting the ion or molecules to hit the surface, but in some accurate particle way. And for the RIE, this will be used as the vertical length or FinFET or the length that needs some deep, but the hole or the entrance is very small. Well, the length can be said as the capacitance here. For the capacitance, if the diameter, the distance is larger, more and larger, the capacitance will be more downsized. It means the refresh frequency will be more faster. But if the distance is very small enough and if the height is enough long, then it means the capacitance is very big and the DRAM don't need to refresh more faster time. And so for the vertical length, vertical length, let's guess, memories here. Well, if we let these memories just being like this, they will affect each other, some plastic cap or electric field or magnetic field effect interrupt. So this will some unwanted result after making the product. So we need someone that work can like blocker or insulator or shield. But this is somewhat very sensitive and needs some super accuracy. So DRI is one of the best way to do this. Okay, maybe the etching is not still end. For the next video, it will be more done finally. Thanks for listening. This was Yu Jung-hee. Thank you.